My dear learner, welcome to Color Pharma. Today we are going to discuss about a assay procedure of combined doses from which contain ibuprofen and paracetamol in a single tablet. So let us start to do the discussions. This is the topic which is given in a syllabus, that is simultaneous estimation of ibuprofen and paracetamol by UV spectroscopy. The well-known brand which contain ibuprofen and paracetamol is a combiflam. Let us perform the assay of combiflam also. So the aim of today's experiment is to perform assay of simultaneous estimation of ibuprofen and paracetamol by UV spectroscopy. One of my video is on only paracetamol assay calculations and procedure. This is for simultaneous. So these are the requirement. Chemicals, we require tablet, most probably combiflam, 0.1 normal NaOH we required. Glassware, 100 ml volumetric flask 1, 25 ml volumetric flask 1, 10 ml volumetric flask 1, pipette 4 ml and 10 ml. Instruments, UV visible spectrophotometer, any models if you have, weight balance, sonigator and filter paper. Let us start the procedure. Suppose this is the tablet given to us, and if you see here, this is our label claim. It shows that ibuprofen is 400 mg and paracetamol is 325 mg. So in the assay procedure, for any assay, we require a 20 tablet, need to take a weight of each and individual tablet, then take the average weight of those all 20 tablet. You are getting something average weight. Suppose we are thinking that we have a average weight is 1000 milligram, right? Now a quantity of powder equivalent to 10 milligram of ibuprofen. Again we will see this calculation for equivalent ibuprofen powder 10 milligram. So 1000 milligram tablet powder contain, we are more focused on ibuprofen, 400 milligram ibuprofen. So we need a 10 milligram of ibuprofen. So how much milligram of tablet powder required? So we are required to do the crush it. So this is 10 divided by 400 into 1000. So ultimately if you see here, this is cancel out, then we get 100 divided by 4, that is 250. 100 divided by 4, this shows that is 25 milligram. Okay, 25 milligram of tablet powder we need to take and transfer into 100 ml volumetric flask. So this is a 100 ml volumetric flask, we need to transfer from this. Finally volume was made with 0.1 normal NaOH sonicate for 10 minutes. So solution need to require a sonicate. So what you should do, the procedure is given like that. You have to take transfer the powder, then add round about 30 ml NaOH, just to sonicate for 10 minutes to all the paracetamol and ibuprofen that come out. After that, make up the volume with 0.1 normal NaOH solution, then filter with the filter paper, that is 0.1 filter paper number 41. If you have normal filter paper, you can take that one also. After make up this, the second one is transfer a 10 ml from this, filtrate, and that filtrate is transferred in 25 ml volumetric flask. Then make up the volume remaining 15 ml, add 0.1 normal NaOH, then you will get this paracetamol concentration round about 40 milligram. It is not required exact, but if it is round about, then it's okay. And the corresponding concentration of ibuprofen. The next is transfer 4 ml from that into 10 ml volumetric flask. Then make up volume up to the mark with NaOH, 0.1 normal NaOH solutions. Then you will get the concentration of ibuprofen round about 16 milligram and paracetamol round about 13 milligram. So next is A1 and A2 were recorded at 226.4 nanometer and 222.4 nanometer. These are the two wavelengths because we have two drugs. So this is a lambda 1 and this is a lambda 2. Okay. Now from this lambda 1 and from the lambda 2, we need to do the calculation that we will see. So AX1 and AY1 are the absorptivity. This value is already given to you, AX1 and AY1. So here AX1 for ibuprofen is 0.0242, for paracetamol that is 0.0351, at respectively 226.4 nanometer. 226.4 nanometer we have taken as a 1. So this is wavelength 1. Similarly, we have AX2 and AY2 that are the absorptivity of ibuprofen at 0.0294 and paracetamol 0.0253 respectively at 2.4 nanometer. I will show you that. After doing this, you need to take the absorbance of the drug or a solution where at a 2 wavelength. What are these 2 wavelength? One is 226.4 nanometer and another one is 222.4 nanometer. At this 2 wavelength, you need to take this absorbance. So let us, this all the procedure I make in a simplified form in a dilution scheme. So what is that? First, weight, tablet powder, equivalent to 10 milligram of ibuprofen. Transfer in a 100 ml volumetric flask. Add 30 ml NaOH, 0.1 normal. Shake for 10 minutes or sonicate. Shake or sonicate for 10 minutes. Okay. Then dissolve a completely ibuprofen and paracetamol. Filter it. Then whatever the filter you are getting from that filtrate, you take 10 ml filtrate into 25 ml volumetric flask. Make up to mark with 0.1 normal NaOH. Then further take 4 ml of solution. Transfer in a 10 ml volumetric flask. Make up volume with, make up to mark with 0.1 normal NaOH. Okay. Now what is the data we have? So you need to take a absorbance. One is A1, another one is A2. So what is A1? What is X and Y? Here X is, we have taken ibuprofen and Y is paracetamol. Okay, so let us see that what is A1? Absorbance at 226.4 nanometer, 226.4 nanometer, and this is absorbance. A2 is absorbance at 222.4 nanometer. This is that you are getting. This two data you will get from this UV spectrophotometer. The second one is AX1 and AX2, AY1 and AY2. This data is given to you already in the procedure. So what is AX1? 0.0242. What is AX2? 0.0294. Okay. What is AY1? Y1 is 0.0351. And AY2, that is 0.0253. This is given in 0.0253. This is given in the assay procedure, right? So this is all things we have concluded in dilution scheme. After getting the absorbance, you have to do the similar way. You will get the Cx and Cy that I will show you, and how to do this calculation, that also I will explain you in next slides. Let us go ahead. The result will be like this. Assay of ibuprofen and paracetamol tablet, brand name this, was found to be a blank percentage weight by weight of ibuprofen and blank percentage weight by weight of paracetamol by Q absorptions method in UV spectrophotometer. The method which is used to detection of both API simultaneously name is Q absorption. Stated value. It is not given in official pharmacopoeia. This combination is not official in any pharmacopoeia, hence need to form in-house specifications. We require to prepare our own specifications or from regulatory body. In-house specification, this hypothetically I have make one in-house specification. The brand name this tablet contain not less than 95% and not more than 105% of a stated amount of paracetamol and ibuprofen. यहाँ पे there we can write that as per in-house specification. So no, that it is not required to do that. We will see in this conclusion. Brand name this tablet was pass or fail as per in-house specification. This is the conclusion we got it. So how to do and what is the principle? What is the principle here is, this is the modification of simultaneous ST equation method. The simultaneous equation method is also one of the method which is used for detections of two active pharmaceutical ingredient which is present in a tablet formulation or any other formulations. So what is the conditions? They must obey the Beer's law at all wavelengths. The Lambert-Beer law that you should know very well about that. Beer's law is based on the concentrations. So ratio of absorbance at any two wavelength is a constant value independent of the concentration or path length. This is known as the iso absorptions. The name of this method is absorption ratio method. So what we have to take? We need to take one wavelength, which wavelength have same absorbance for both the drug irrespective of wavelength or concentration. I show you that. So suppose we have taken a two wavelength. What are the two wavelength? One is isoabsorptive point. So this is our isoabsorptive point. If you see here, this is what happening then. The happening is the irrespective of concentration or irrespective of wavelength, the absorbance of both the drug are same. Let's see. Okay, absorbance of both the drugs. So we have taken 226.4 nanometer. And the second one is, we can take a wavelength maxima of any drug. We have taken this one for ibuprofen, but we can take this is also, but we require to optimization of that procedure. So in optimized procedure, we have taken this two wavelength. So if you are getting the isoabsorbance in your drug or in a combination individual API, then you can apply this method also. So equation for concentration measurement, say Cx, x is what? X is ibuprofen. We have Qm, A1 we will take from this absorbance at a wavelength 1 from the UV. Ax1 data is also given to us. We require to calculate Qm, Qy, Qx and Qy. That I will show you. Cy, this is a paracetamol. This is a paracetamol concentrations. Cy, we have A1, then Ay1, then Qx, Qx, Qy and Qm. Then after getting this one, we need to take a consideration Qm. What is Qm? Qm is A2 divided by A1. A2 divided by A1. And Qx is what? The Qx is Ax2 divided by Ax1 and Qy is Ay2 divided by Ay1. So in both the case, we are measuring Qm minus Qy, Qx minus Qy, that is A1 upon Ax1. This is Qm minus Qx, then Qy minus Qx, A1 and Ay2. This is the assay procedure which is we have to take in considerations. Okay, let us go ahead. And for the calculations, you may go through the one of my video for assay calculation, which is given in right corner of your video. From that you can find the calculations, study questions, and list a different method used for simultaneous estimation by UV visible spectrophotometer. Second one is comment. Chromatography is better than UV visible spectrophotometer for simultaneous estimations. Third, write down a combined formulation available in pharmacopoeia. Fourth, write down a condition of a spectrum for simultaneous estimation equation method. So you should write what is the condition required for simultaneous estimations of simultaneous estimation method. So what condition to be fulfilled by the spectrum of both the drug, and list different analytical technique used for the assay of a formulation. These are the last question. So this is my attempt to show you how to calculate a simultaneous equation method that will help you to understand the concept of absorption ratio method. Thank you. Thanks a lot.